Hey guys, welcome to Great Learning. If you're a person who's preparing to ace an upcoming Python interview, I am sure you're very curious to learn some of the most important questions that have the highest probability of being asked, correct? Now, Python is a very vast programming language and it becomes key that you spend time on the right questions and to focus on important topics. Now, keeping this in mind, we here at Great Learning have come up with this Python most asked interview questions video where we'll be discussing 30 super important questions. These questions are the absolute cream of the crop, so make sure you're not missing out on any of these, right? Well, with that, I know you guys are excited to take on these super important questions. So what are we waiting for? My name is Anirudh Rao. Let's get started. Since you're starting this video, you are clearly preparing for your dream job. So before we get started, I have something exciting for you. If you are finally a student or a fresh graduate with less than 1 year of job experience, Great Learning brings you this unique job readiness platform called Career Plus, where you can apply to 400 plus corporate hiring companies. Sounds exciting? Complete this video and check out our platform Career Plus, where you can quickly take a job eligibility test, pass it and apply for the relevant jobs. If you do not score well, don't worry, we have your back. You can prepare from our specially designed courses and take the test again to improve your score before applying to jobs. More than 500,000 students from 2,000 plus top colleges chose us and secure jobs paying up to 10 lakhs per annum. So why wait? Check it out and join for free today. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleagues, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments. Alright guys, look at the question. The question states, how do you implement a probability plot using NumPy and Matplotlib? Now this is a very specific question. If you have mentioned that you have worked with NumPy, I am confident that all of you all have. There's a good chance you might have not worked on Matplotlib, but they want to test your ability of how well you can graph something out, right? Now a probability plot is basically using random functions to eventually print one plot wherein every time you execute it, since the data that you're providing it to be random, it will of course create random probability values and map it on a probability curve, right? Now this is what the curve looks like as and when I run it once. Now all of this is random because what we're trying to do is we're trying to use random values in itself, right? If you had data to create this plot, fantastic. In this case, it was a random question that was asked, so eventually we'll have to create our own data. Now that you've taken a look at this output, let me run it again. Now, as soon as I run it again, you see that entire pattern got shifted. Why? Because every single value was randomized, it got changed, and we have new probability values that are present here, right? So guys, you have to be careful if you ask questions like this. Now, here is the code again. All we're trying to do is import NumPy. There's a fantastic library called PyLab. And of course, guys, you have to know about SciPy and Matplotlib, right? SciPy it's called Scientific Python. It's a fantastic library to work with. And eventually we have Matplotlib, wherein we're trying to import PyPlot. Now Matplotlib, PyPlot, Seaborn, all of these are super important data visualization libraries in Python. Alright, fantastic. Let's move on to question number 2. Question number 2 states, given the sample dictionary, how would you update the value of apple from 10 to 100? Well, given the sample dictionary, how would you go on to update the value of apple, right? Now the apple value is 10. Apple 10, orange 20, banana 30, guava 40. Now what they want to do is take out this 10 and input 100. Right? Now, it's a very simple thing. All you have to do is this. But no, you already have an input that you have to work with, right? It's pretty simple, guys. It's very straightforward at this moment of time. They will try to confuse you by maybe giving you a lot of these values or maybe changing the structure of how they have denoted this as well, right? It's only to make sure that you get tricked and you don't know the logic. You cannot figure out the logic. But fret not. All you
you have to do is fruit of apple. What's the column that you're trying to access the data of? It's 10. We don't want 10. What do we want? We want 100, right? Just one line of code will eventually go on to change that. Now, as soon as I run this, you can see that even though input is apple of 10, the output is apple of 100. This seems like a very easy question, but there are n number of chances where either you're a beginner who can mess up the logic and not understand, okay, how can we do this? Because again, if you just wanted it in real time, all you would do is change the input itself, but the input is fixed, the output is changing. So make sure you guys are paying attention there. Right? Fantastic. Coming on to the third tricky question. It states, how do you find the common elements that are present in two given sets? Okay, we're talking about sets. What is the most important thing that you have to understand about a set? Every single element is basically unique, right? Now, if I give 1, 2, 3, 4, 5, 6, and if I have another 6, S1 is a set which just has 6 unique values. Even though you see 7 right now, it doesn't care about any repeated values. You can have any number of repeated values, they're all ignored, right? So we have two sets, 1, 2, 3, 4, 5, 6. We have a second set, 5, 6, 7, 8, 9. Take special attention here. It says 5, 6. These are already repeated here, right? Now, as soon as you go on to intersect using the S1.intersection, what are we trying to find out? The common elements that are present here. The common elements that are present here are what? 5, 6 and 5, 6. Do not get confused of how a set works because that's what I just mentioned here. But the question is asking the common elements in two sets, not a single set, right? In that case, the intersection function works beautifully well and you will see the common elements. I'm sure we would have learned all of this back in our school or in our college, right? Intersection, union, all of these functions. All right, guys, superb. Coming on to the fourth question now. The fourth question states, implement the logic to check if a number is a palindrome or not. Now guys, if you are a fresher or if you have somewhere around 1 or less than 2 years of experience, this question has to be the question that usually get asked. In fact, we have multiple questions. All the 30 questions that we're going to discuss right now are super important for both beginners and experienced people. Well, how do you know that a number is a palindrome or not? Now, let me just hit enter because I want to actually type in a bit of comments for you guys right now. Now, is 10 a palindrome? Well, 10 is not a palindrome because if you reverse 10, you get 0 and 1. 0 and 1 is not the same as 10. But what about 121? 121, even though you write it backwards, is still 121, right? That is basically what a palindrome is, guys. When you reverse it, it has to remain the same. Now, this entire reverse logic, again, is super common, super popular. If you're at this point of time, you guys should know this logic. If you do not know, pay attention. All we're trying to do is assign a value of n to temp. We have rev equal to 0, rev talk about reverse, and we are running a while loop. While n is greater than 0, first of all, find the modulus of the number with respect to 10. We're trying to cut out the unit digits and we're trying to remove the place value. Now, when I write 121, it's not just 121, it's 121, right? To make sure that we remove all of these place values and to make sure that we have the reverse of it. First of all, this entire thing, guys, is nothing but reversing the number. What you do after reversing is check it with respect to the original. You have the original, you have reversed it, compare. If it's the same, done, it's a palindrome. If it's not same, it's not a palindrome. That is literally the logic, guys. 4 or 5 lines of logic, but a fantastic program. Let's just enter 10. It's going to say 10 is not a palindrome. Of course, it's not. Let me run it again. Now, let's try a really complex number, 13331. Or let's have this number, right? 213312. As soon as I go on to run this number is a palindrome. Why? No matter what side you write it from, it's going to be the exact same value, right? First of all, we're removing the place values, we're reversing it, and we're comparing a reverse operation to the original one, and we are done. Superb, guys. Now, coming on to the fifth question. Now, for a couple of questions from now, we'll be discussing pattern questions, guys. Pattern questions are absolutely asked. I don't want to say that there is a high probability of being asked. I know for sure that these questions get asked in most of these places, right? So be it startups, be it multinational corporations, these are very common standard questions that they're going to ask. So if you know how to tackle this, well, you're in good hands to land a fantastic job. Look at the pattern. What is the pattern trying to say? If you take a look at it in the column aspect, it says 1, 2, 3, 4, 5. The next one, there is absolutely nothing. We're starting from 2, 3, 4, 5. Again, 1 reduced, 3, 4, 5. Another dimensional reduced, 4, 5. Another one which just prints out 5. Now how can we go on to think about the logic? Well, we have two loops here. One is to control the range of the data. The other one is to control the movement of the data in itself, right? So you can see that input in range of 6. Now, why are we taking this to be 6? Well, all we are trying to do is understand from the range from 1 to 5, right? We want 1 all the way to 5. For I in range of input number, well, basically it's the input number here. All you're trying to do is print it, give out one space in the middle. And once you do this once, you will have 1. Next, you'll move on to the next line. You'll print 2, 2. Once you move on to the next line, 3, 3, 3. So the program is executing this in a row-wise manner. 1, 2, 2, 3, 3, 3, 4, 4, 4, 5, 5, 5. Similarly, let's go on to run this program and you will find the same output, right? The execution is happening row-wise, but you can go on to understand it column-wise as well. And again, with these tricky questions, you might be asked for more than one way to actually solve the same problem, right? So make sure you're paying attention there as well. Now, this was fun. All we had to do is print the numbers. But what instead of numbers is a simpler question, maybe for a beginner, that says, hey, I have a couple of hashtags that I wanted printed with this left justified triangle, right? So it's always 1, 2, 3, 4, 5, 6, 7 elements in each and every row that I just mentioned, right? All you have to do is create a function called as pattern print. First of all, we're going to be starting from 0 because the first time we want a count and a print, we just want one hashtag there. What are we doing? If we printed this once, have a tracker or a flag there to ensure that you're telling Python, hey, if this was printed once, add 1 to it and print it that many times. If this was printed 2, add 1 to it and print it these many times. That's it's 1. Python knows it's printed it 1 time. Next it's like, hey, I have to print it 2 times. Next Python is like, I have to print it 3 times. And that is it, right? Of course, they've asked you for 1, 2, 3, 4, 5 rows. That's the reason we'll be sending the value of n to be 5. Now, let me go on to run this piece of code and you can see that it is there. But what if you want maybe 6 rows instead of 5? Well, big deal. Just send the value of 6 to the function and it will go on to print it using the same logic, right? All right, let me just turn this back to 5 so that you guys have the correct notebook with respect to the question. Superb. We have 5 rows. We have printed the hashtag. This one is actually a bit simpler compared to changing numbers or moving with respect to digits, ASCII values, all of that. All you're trying to do is print a hash. Eventually, we don't have any spaces here because the input does not have any spaces. In fact, if you want spaces, just put a space here, go on to hit print, and you have beautiful looking white spaces in between as well. Simple, right? Well, let's jump back to take a look at more numbers. This time we're not taking a look at 1, 2, 2, 3, 3, 3, 4, 4, 4. We're trying to have all the columns as 0, next columns as 1, next columns as 2, next columns as 3, 4. But we're trying to reduce one dimension every single time we go on to do this, right? So take a look at the pattern, write down the pattern and see if you can build all the logic on your own. Guys, any of these tricky questions that we are trying to discuss, I want you guys to pause the video wherever you find it fair. Pause it, try to write the logic on your own and later compare it with what I'm teaching you guys. Or in fact, if you find another method to achieve the same thing, you can do it. There are many methods of how you can solve this particular problem, right? But it's very important that you think of it first rather than just taking a look at the output and saying, I got it, right? It can get very confusing during the interview as well. Now here again, we'll be considering 2 loops. We have the outer loop here. This outer loop completely handles the number of rows that we'll have to print, right? How do you know that you're going to print? We can understand it as humans in a columnar fashion, but Python looks at it as rows. So how many rows do we need? 1, 2, 3, 4, 5. So basically the number that we are going to have to input here is 5, right? That is the outer loop that discusses the number of rows. Now we need to print the actual numbers after we understand how many numbers we have to print. That is where this comes into the picture. The inner loop talks about the logic wherein you just find a number, add 1 to it and just print it out. If it's 0 in the first row, you just jumping directly to the next one. The next line, as soon as you see 0, you'll have to add 1 to it and print that element. Again, jump 0 plus 0, 1 and again 2. right? So you're basically jumping one line and just attaching one more element there. You'll have to do it in order, and this simple loop is going to do this, right? Now let me remove a couple of spaces here so that you guys can look at this better. This is the entire logic, guys. Now that I've just hit the play button on this piece of code, it says how many rows do you want in your pattern. Now how many rows are they expecting? 1 2 3 4 5 rows. All I'm going to say is, hey, give me 5 rows. And as soon as I hit enter and scroll, you'll see this, right? 0 0 1 0 1 2 0 1 2 3 0 1 2 3 4, right? Guys, I hope we are clear with these 3 pattern questions that we discussed, because the next pattern question that we're about to discuss talks about the Pascal's triangle pattern. Pascal's pattern, factorial, reversing a number, all of these are really common questions that get asked. So you have to prep for this and you have to know this by heart, right? Well, what is the Pascal's triangle? The Pascal's triangle basically gives you an output that looks like this, guys. You can see the comment that has been made here, right? So, you have to understand how the variation in terms of permutation and combination works, because here for a Pascal triangle, the values are 0C0 and 1C0, 1C1. We jump to the next line, 2C0, 2C1, 2C2. Jump to the next line, 3C0, 3C1, 3C2, 3C3. Jump to the next line, 4C0, 1, 2, 3, 4. Again, for 5, it's 5C0, 5C1, 5C2, 5C3, 5C4, 5C5, and so on, right? This is the pattern that we want to print. But instead of printing 1C1, we have a formula for NCR, right? It's n factorial by n minus r factorial into r factorial. This is a very important formula for understanding the combinations aspect when you're learning permutation and combination. It's a very simple thing, guys. We're trying to import the math function. From the math function, we're trying to import factorial, because all of these things, instead of manually finding the factorial, we have a function that will do it for us easily, right? In our case, x is basically n, y is basically r. It's basically n factorial by n minus r factorial into r factorial, right? Let me go on to run this piece of code, and as you can see, it's going to give you an output which looks like an actual triangle. This is what? This is 0C0. What is this? 1C0. What is this? 1C1. 2C0. 2C, anything, NC0 is always 1, right? That's the reason all the first columns is going to be the same, but all the last values is also the same. What's with that? Well, 0C0 is 0, 1C1 is, 0C0 is 1, 1C1 is 1, 2C2 is 1, 3C2 is 1. Now, how am I saying all of these? Well, I know the concept by heart, and if you just run the values by calculating the factorial, this is the exact output that you're going to get, right? So printing the pattern should not be of any confusion, but the logic that you put inside the pattern is happening in one particular line, guys. Again, the outer loop talks about how you're traversing around the triangle, but the inner loop talks about what exactly it is that you are putting in this particular loop, right? So there's a very important question, guys. Make sure you are acing this when you are asked. Now, with that, coming to the next question, the 9th question. Here we don't have hashtags. Here we don't have numbers. We don't have anything else. We have A, B, C, D. Now, A, B, C, D are these characters. Of course, you already know this. Now, how do you go on to print a character and make Python understand how to print capital A, capital B, capital C? Well, Python understands characters and so in terms of a value called as the ASCII value, right? So all we have to do is find out the ASCII value for this, keep incrementing it everywhere, and just like the number solution 0, 1, 1, 2, 2, 2, 3, 3, 3, 4, 3, 3, 3, 4, 4, 4, 4, it's the same logic there, but instead of passing a number, we are trying to just pass the ASCII value, and once the ASCII equivalent is printed, it's nothing but A. Now the capital A, the ASCII value for capital A is 65, capital B is 66, capital C is 67, so on, right? There's an entire list that you can have. So all they're trying to do is ask for 4 rows, and again the outer loop always handles how many total rows that you want. This number is the magic number. The input loop, however, basically talks about how many columns that you want here. Now, how many columns are we expecting here again? Of course, since this is a left justified triangle, if you have 5 rows, you'll have 5 columns as well, right? And here is where the magic in terms of having the ASCII equivalent happens. You input 1, you input 2, you input 3, or you give any sort of character to it, you will have the ASCII value. So we have to convert the given character into ASCII, convert the ASCII back into the number, just print it out. We want 4 rows of ABCD here. So as soon as I go on to print this piece of code, it says enter number of rows. Let's just put in 4. As soon as I hit 4, it should go on to print A, B, B, C, 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 D, 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 right? This lines eventually you'll have to increment it because we want to understand that there are more rows, right? We're talking about the inner loop where we're trying to move around the triangle. So whenever you guys are executing this alongside me, take a second to understand how not only the flow of the for loop works, but how the inner loop also talks with the outer loop, right guys? That's a very, very important thing. Fantastic. We have printed this pattern. Now, there's a very good chance if they're asking you a lot of pattern questions on characters, they're going to say, hey, okay, so why don't you print us the entire alphabet in this particular order? A, B, C, D, E, F, G, H, I, J. So basically for every row, there is one increment in terms of how many numbers can go. First row, 1. Second row, 2 digits. Third row, 3 digits or 3 characters. Fourth row, 4 characters. Fifth row, 5 characters, and so on, right? Now this makes our job very easy. We're doing the same thing. We're converting the number equal to 65 because this is the ASCII value. Later, we're sending it to the program to say, hey, whatever is the value or whatever is the digit or the character that has ASCII 65, print that for us. Similarly, the outer loop talks about the number of rows. The inner loop talks about how you can, how the values actually change into these particular ASCIIs, right? This is where we can doing the ASCII value conversions, and this is where the ASCII value conversion is happening. Sorry, and this is where we are trying to implement a jumping and increment every single time. Now, how many rows have they asked, guys? 1, 2, 3, 4, 5, 6. Let me go on to print, let me go on to run this, and let me just type in 6. We will have the output to our particular answer. But since we are running ASCII values, you have to understand that, what happens if I input 10? Now, there won't be so many ABCDs to put there, right? Look at this. Z ended pretty much even before it came to a point where it could end it in the triangle itself. But after that, whatever is the ASCII value of capital Z, the next ASCII value is a left bracket, all of these operations that are there. You have to understand that capital A's ASCII value is extremely different from the lowercase ASCII value. That's how the computer understands the difference between a capital A and a lower a, right? So even if you have to do it for 10, all you have to do is input 10 and finish it, guys. Now let me go on to input 6 again, and we will have the required output. Now guys, make sure you're taking it slow, pause the video, watch out for how I'm explaining in terms of what each of these loops does, and work along with it side by side as well. Alright, superb. Now coming on to the 11th question. The 11th question says, if you have a dictionary like this, they have already given you the dictionary. This is K1 of 10, K2 is 20, K3 is 30. Okay, this is a dictionary. What do I do with the dictionary? The question is, how would you increment the values of all the keys? We're not trying to use the replace function to replace one value, nor can we use the replace function 100 times to do this manually. So how do we increment all of these, right? So it's a very simple thing. Just take the same dictionary, make sure you are running a loop, because a looping operation, since it's a common operation that's going for all the values that we're trying to increment. Now, what are we trying to increment? They're asking increment the values of the keys, right? Of the keys. We want to make sure our key value will go up 1. So all I'm trying to do is I'm trying to take d1.keys in a function. For every I that is present there, just add one more. Now, as soon as I go on to print d1.values, you'll see that it should say 11, 21 and 31 instead of 10, 20 and 30. What if I want to add 10 to it instead of 1? It's a simple change of logic there. Just run it again and you can see 10 got added, right? Instead of 10, it's 20. Instead of 20, it's 30. Instead of 40, instead of 30, it is 40, right? Simple, guys. It's a very simple piece of code, but whenever you ask this in the interview at that moment of time, there's a good chance you might stumble upon something in this logic is not right. You're not able to figure out how to print it, or you're not figuring out how to work with the looping statement as well, right? Now, I'm sure this will give you a good amount of clarity to go about doing that. Alright guys, coming to the 12th question. The 12th question states print random numbers using the random library. Well, you can do it two ways. One, you can just print any number that you want from the library using this tiny piece of code, but they can also say ask you a question saying, hey, I want to print random numbers but in a specified range. So let's just say that they want to print all random numbers between 10 and 20, right? Now you can go on to hit play, as you can see here, any number of times, and every time I do it, the first number is going to be a value between 0.0 and 1, and the second value, where we're using the random function, we have the range that gets specified here. So everything from 10 to 20, including 20, that's 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All of these will be printed in a random order. There is no order to this. Every time I go on to run this, it will just print out one random value, as you can see. Right? Fantastic, guys. Now moving on to the 13th question. The 13th question says denote the usage of args and kw arguments in Python. Args, it usually starts with the star args and double star kw args, right? Like just like this, the function arguments here. Now, what does args give us that kw arguments does not give us? Well, first of all, you have to understand that if you have any unnamed arguments, your args is going to pick it up. If you want any named argument, your kw args is going to pick it up, right? Take a look at this. I have passed in three parameters to this particular function called func1, and first of all, we have two values which don't have any sort of names associated with that, but third one has my name. My name is Anirudh, right? Now this is going to go and be picked up by kw args, while these two will be picked with arguments. If I'm just printing the unnamed arguments, I'm going to have an output of 1 comma hello, but if I also want the named arguments, it's going to of course print Anirudh as well. Simple, straightforward, yet you can be pretty much confused if you do not know that you have to pass a named argument for kw args to work, right? Now if you miss this particular thing, this particular line, you will still get the output correct for args. This will just be put into args and you'll be breaking your head about why it's not kw args. It's not kw args because there is no name associated with it. Make sure you're compulsorily giving a name there as well, right? Superb. Now coming on to the 14th question. The 14th question talks about a beautiful copy operation in Python which can get very confusing. It's called as the shallow copy in Python. For the people who do not know, there are two types of copying that you can do in Python. There's something called shallow copy, there's something called deep copy. Deep copy basically allocates completely new memory, copies it from one place, keeps it in the second one, and the first one remains untouched, right? That is you just taking one banana, eventually making two more bananas out of it and not touching the main banana. The one banana is going to still remain there, right? Now here we have one list, the first list with 5 elements, 1, 2, 3, 4, 5, and all I'm trying to do is second list equal to first list. So I'm copying everything that's present in the first list to the second list. But then I'm doing one more operation here. I'm trying to append E to just the second list, right? So as of the output should, now that we're printing first list and second list, the output should be 1, 2, 3, 4, 5. Next line, 1, 2, 3, 4, 5, 6, because we are adding 6 to the second list. Will that be the output? Absolutely not. We're not doing a deep copy, we're doing a shallow copy. Since the second one is referring to the same address of where first underscore list is, the second you change the second list, the first list's value also gets changed. There are many advantages of why you would want to do this, but mostly it's tiny bit of disadvantages which can get eventually confusing. You'll be breaking your head about why this is happening. I haven't attached 6 to the first list. It is happening because it's not your fault. The memory allocator in Python is basically taking the second list, instead of creating a new memory allocation, unless you want it, it'll be using the same one and eventually it'll attach it to the first one. Because regardless of you printing second list, regardless of you printing first list, the changes happen in both because both of them are in the same memory location, guys. It's as simple as that. Right? Superb. Now coming on to the 15th question, guys. The 15th question states, what will be the output of the following piece of code? Now let me zoom in a little so that you guys can see this better. Now ladies and gentlemen, even before I hit execute, and I'm very sure even before you hit execute on your notebook, try to guess, try to see what they're asking about. A of -1 says, hey, start indexing everything from the last. The next one, the hyphen -4, states move 4 positions back. Okay, moving 4 positions back, I am at the 6. The next one, which also says -1, is basically saying take single steps to move, right? Instead of going from 9 to 7 to 5, instead of jumping 2 at a time, just jump 1 at a time in the reverse order. Now, as soon as I run this, the output that I'm supposed to have should be 9, 8, and 7, right? Because this is -1. We're trying to go to the last one. Print the last one, jump 1 step behind, print the second last, jump 1, print the third last, and you're done. You might be a person who's saying, hey, it's -4. Should we not have 6 also to be printed? See, it's -1, -2, -3, -4. But when we're using a range function, everything between this and excluding this is printed, right? If you also want 6 to be printed, all you have to do is change this to -5. As soon as you hit -5, everything until 6 is printed, but it traverses through 5, but 5 is not printed, right? So this is very important question, guys. So it can be something as simple as this. If you just hit -2, you'll basically get 9 and 7 as the output. You're just skipping it twice, right? So you can be asked any sort of questions around this. So make sure you're very, very confident with even the most simplest questions such as this. Alright guys, now to talk about the 16th question. The 16th question states, how do you print the ASCII values of a given character? Now we already discussed the section where we're taking a look at a lot of ASCII characters when we are printing the patterns out, but you have to understand that they're just saying, hey, I'm going to give you a value, just print me the ASCII for it, right? Now there are two functions. CHR basically converts an integer to back to its character, but the ORD function basically takes the character and converts it eventually to a number, right? Now as soon as I hit play, it'll just print me the ASCII value of small a, which is 97. Now what was the ASCII value for capital A that we just discussed, right? It is 65, right? As soon as I go on to print it, it says 65. Now it can be anything. They can ask you the ASCII value maybe for capital Z. Well, of course, any value that you pass on is pretty simple. You can also implement the logic where you're just putting in this entire thing in an infinite loop and just saying, hey, input a value, I'll print out the ASCII. So as in when you start punching in the ASCII values, the output is straight up. As in when you start punching in the characters, the output is ASCII values, right? 16 is very straightforward. All the logic just lies with this. The entire working, the answer to this entire question is only here, but to just make it a little beautiful to look at, we're just doing this, right? Fantastic, guys. Now the next question, the 17th question states, what is the easiest way to shuffle a list? Shuffling a list. Why would you want to shuffle a list? Well, it might always be a case wherein you want to quickly randomize all the elements that are present in your list, right? Instead of you importing the random function, using the random.random, creating your random values, or in fact using the values that are already present, we'll still be using the shuffle part of the random function. But here we have one list. It says, you'll never walk alone. This is basically the slogan of my favorite football club. If you do not know the slogan for the football club, it's basically Liverpool, right? So now as soon as we hit shuffle off this particular list, it will give me one random output every time. See, alone, never, walk, you'll. It basically reverse the entire thing. Now it's not done on purpose, it's random. As soon as I run this again, it says walk alone, never you'll, right? Let me run this again. It'll say you'll walk never alone, right? You can see that it's shifting around and moving it. So if ever you think that there is some sort of bias in the data that's present, and if you can jumble it around and still work with the logic, you can remove that random bias. It's called as random bias, guys. So you can remove that to work with it. So the simple, again, the logic is just one line of code, but when you're in an interview, you really should know this as well, right? Superb. Coming on to the 18th question. The 18th question states, how does floor division work in Python? Absolutely fantastic, guys. Now I want all of you all to pick up your calculators because we're going to be doing some calculation here, right? You can in fact do all of this manually as well. I'll ask you math questions. Don't look at the syntax there. What is 5 divided by 2? 2.5. What is minus 7 divided by 2? Minus 3.5. What is 7 by 2? 3.5. What is minus 7 by 2? Again, minus 3.5, right? Fantastic. Now all of this is good, but there is a difference between just division and floor division. Floor division basically just removes the floating point number and just crashes the entire value to the next lowest value, right? Now as soon as I run this, the output should be 2, -4, 3 and -4. Yes. Now why is this? This you would have understood, right? 5 by 2 is 2.5. Just throw the 0.5 away, you get 2, right? Superb. That's correct. Now, take a look at 7.0 by 2. This is also correct, right? 7 by 2 is basically 3.5. Take the 0.5, kick it out, you get 3 and eventually you print this. Since it's a floating input, you have a floating output. Python is very intelligent to understand since it's a strongly typed programming language, right? Fantastic. But these two lines where I'm putting in a hashtag right now, the comment, this is where something is missing. -7 by 2 should give me -3.5. If I check out the 0.5, my answer should be -3 and not -5. Correct? This is a question that the interviewer is going to ask you to trick you. The answer is no, because if you take a look at the number line and if you have -3.5, what is the lower value compared to -3.5? It is a value which is still lower than -3, which is what? -4. It cannot be a value higher. We are trying to use what division? Floor division. We are trying to floor it to the lowest values, right? That is the reason why this gives you -4 instead of -3. Be very, very careful at this. The interviewers are going to try to trick you to say, as soon as you you say that, hey, -7 by 2 gives me -3.5, they'll be like, are you sure? Now the next thing you might say is, okay, it might give me -4. Then also they'll be like, no, don't you think it's -3? They can confuse you a lot, guys. So be very careful with the 18th question. But now that you know how to tackle it, I am confident that you guys will handle it well, right? Take a look at question number 19. Question number 19 states, denote the usage of pass by value and pass by reference. It's also called as call by value or call by reference. It's a simple concept, guys. Whenever you're trying to change the scope of a variable, wherever you want to pass the scope of a variable, you just want the changes to happen in the new memory allocation rather than the old one, right? Just like shallow copy and deep copy. If you call something by its value, the memory address remains the same. So all you're going to get is the value that you asked for. If you pass it by reference, what Python is doing in the backend is it's sending the memory address of where the data is stored. So if you make any sort of changes to the memory, the memory address there, the data that is stored in the memory address, it will change everywhere regardless of the scope of the variable. So call by value will only change it in that scope. Call by reference is where you're just sending in the address saying, hey, you do whatever you want with this address. You can copy, delete, move, change. In that case, the changes will be reflected everywhere, right? Let's take a look at this. We have a very simple array, 3 elements, 1, 2, 3. And if I just go on to print it out, it's call by value, right? Call by value is the same. It's going to still give me 1, 2, 3. But when we run call by reference, I am trying to take it to this particular function. I'm inputting the array value there and I'm appending one more element, 4. Now you have to understand that we just passed the memory location to 4 and eventually it understood that saying, hey, there is 1, 2, 3 already, let me just attach on to the same thing. It figured out that there is 1, 2, 3 not by the value themselves or the array itself, but by the memory location where the elements of this array is stored, right? Again, call by value, call by reference are really basic stuff that you must know at this moment of time, guys. If you do not know, it's okay, pause the video. There's many articles wherein you can figure out what call by value or call by reference is, but as I just mentioned, it is literally that. So even if you are asked a theoretical question, you can literally state the answer that I just stated, right? Fantastic. Now this has to be a question that gets asked every single time, ladies and gentlemen. It says, hello world, double colon of -1. Double colon of single colon of -1 will basically give you the output of the last character. But you look at this, right? We're just moving on to the last one and just printing everything there. Now, what if there is a double colon here that says double colon of -1? This is a very simple shortcut to take a string, reverse the entire string and print it out. Look at this. Hello world became completely reversed, as you can see, right? So basically -1 is saying traverse everything from the last instead of the first. right? If you start writing everything from the last to the first, of course it's going to reverse itself, and that is the output that we see. If you are a beginner Python user attending a Python interview, there is a very good chance you'll be asked these indices tricky questions, right? As we discussed previously as well, we took a look at multiple questions there. Make sure you are understanding the heart of the logic here. Right? Superb, guys. Let's discuss the last 10 questions that I have for you today. Now, 21st question states, what is the output of this operation on a list? List multiplied by 2. Now, this is a super tricky question. This is where a lot of people go wrong, that I have seen personally as well. Now, I have a list with 5 elements, 1, 2, 3, 4, 5. As soon as I multiply it with 2, what do you think is going to happen? 1 becomes 2, 2 becomes 4, 3 becomes 6, 4 becomes what? 8, 5 becomes 10. Correct? Answer is absolutely not, because the asterisk operation will copy that element into another. So instead of you guys getting 2, 4, 6, 8, 10, you're going to get 1, 2, 3, 4, 5, but twice this time, right? Now, this is a very, very, very confusing, output, even to someone who has worked with Python previously. At the heat of the moment, if you're asked this question, you will just want to say that all the elements will get doubled. If it is into 3, there is a very good chance you can say, hey, we are just tripling it, right? Because this is a multiplication operation that we usually use. But do not be confused, guys. If you use this operation with respect to a list, all you're trying to do is replicate the elements once again. So if it is 1, 2, 3 instead of 1, 2, 3, 4, 5, what do you think is going to be the output? It's going to be 1, 2, 3, 1, 2, 3, right? Look at that. Fantastic, right? It's very simple, very confusing, a fantastic chance for the interviewers to trick you. Okay, coming on to the 22nd question. The 22nd question states, write the logic to check if the given number is an Armstrong number or not. Ladies and gentlemen, this is a question that has to be asked, because they want to understand, the interviewer wants to understand if you know what an Armstrong number is. The second thing they want to know, if you of course can work with the logic, if you can work with the syntax and all of that, right? Now, an Armstrong number is pretty simple, guys. Basically what we're trying to find out is the cube of every single digit. Now, if I input 153 and if I want to find out if this is an Armstrong number or not, what is 5 cube? 5 5s are 25, 5s are 125. Correct? Simple. What is 3 cube? 3 into 3 is 9. 9 into 3 is what? 27, right? Now, all I did was take this digit, find its cube. Take the second digit, find the cube. Take the third digit, find the cube. As soon as I did this, just add all of these values. 125 plus 1 is 126. 126 plus 27 is 153. So no matter what number you provide, if all of those cubes add up to this number, it's called as the Armstrong number, guys. Now, if I just put in 10, right? This logic is wonderful. What if we discussed not an Armstrong number? Not an Armstrong number. Let's just take 10. Right? If 10 is your input, the first digit is what? Cube. Cube of 1 is what? 1 into 1 into 1 equal to 1. What is the cube of 0? 0 of cube is 0, right? Now, is 1 plus 0 equal to 10? No, 1 plus 0, even though 1 cube plus 0 cube is not equal to 10, it's only equal to 1. Hence, 10 is not an Armstrong number. Similarly, for 407, 4 cube plus 0 cube plus 7 cube is eventually going to give you an answer 403. Right? Now that we understood what an Armstrong number is, this is the entire logic, guys. This is pretty much the logic. All we're trying to do is take the input from the user. The user can input any number he or she wants while they input a positive number, right? You have to make sure that it's a positive number. While they input a positive number, all you're trying to do is trying to find the cube. As I told you, here also we are taking the place value, right? This is not 153. This is 153. So we are removing the place values, creating individual numbers out of there, cubing it and finding one sum. If your input number is equal to the sum of the cubes of all the individual digits, it is an Armstrong number, else it's not, right? It's very, very simple, but if you do not know what an Armstrong number is, you cannot attack this problem, right? First of all, let's input 10. 10 is not an Armstrong number. Now, as soon as I run this, it says 10 is not an Armstrong number. Fantastic. Let's run it again. This time, let's push the values 407. 407 is an Armstrong number. As soon as I run this and I come down, it says 407 is an Armstrong number, right? We understood what an Armstrong number is. We understood the logic that goes on to working with an Armstrong number, and we also figure out a way to print if its given number is an Armstrong number or not, right? If you were a person who just said, okay, so Armstrong number is done, which number next? Well, the next number that you'll have to take a look at is a perfect number. Now, what is a perfect number? We know what an Armstrong number is, but what is a perfect number? A perfect number is basically sum of the individual divisors of all of these values, right? To find out if 6 is a perfect number, what are all these digits that you can divide 6 with, right? 1 into 6 is 6, 2 into 3 is 6, 3 into 2 is 6 as well. So 1 plus 2 plus 3 gives you 6. The logic is simple, guys. So all you have to find out if this is a perfect number or not is take all the divisors out of it. Every number that gets divided, just add it on, you will get it, right? Now, if now that we've said that even 28 and 8128 are also perfect numbers, let's actually find out why 28 is a perfect number, right? Now, for 28, what is the logic that you think you should follow? Find out all the digits where 28 is divisible. It goes with 1, it goes with 2, it doesn't go with 3, it goes with 4, it doesn't go with 5, 6 doesn't go, guys, 6 table. Are you guys calculating? 6 4s are 24, it will not go, right? So 7 3s are 21, 7 4s are 28, right? Yes, 7 also works. Now 7 is done. Does it work with 8? I don't think so. Does it work with 9? No. 10, of course, no. 11, no. 12 now is 12 2s is what? 24, so no. Does 13 work? No. What is the next one that works? Well, it's 14. Everything excluding the number itself, right? Now, of course, even 28 into 1 is still 28, but the logic of a perfect number is to consider everything apart from this number, right? Now, let's add this. 14, 15, 16, 17, 18, 19, 20, 21. 21 plus 7 is 28, right? So, the individual sum of all of the digits, if you get the input digit back, simple, it's a perfect number, right? The logic again is very simple. Just break the number down, remove all its place values, consider each individual digit, sum it up. If your sum is equal to the input, tada, it's a perfect square, right? All you have to do is find the divisors. Look at it, look at the logic here. It says number mod I equal to 0. If it divides the number perfectly without any reminder, find all those ones and make sure that you're just printing it out at the end of the day, right? So let's just put in 6 and 28 now. As soon as I put in 6, it should say 6. Hang on, I have an error here. Now, let's just actually go on to track why this error is there. Okay, my bad. It doesn't know what capital number is, right? Because this doesn't stand for capital number. This stands for number input, right? As soon as I hit run again, it should work fine now, guys. Let me go on to hit 6. As soon as I hit 6, it says 6 is a perfect number. Let me run it again. Let's take a look at 28 now. 28, we already saw how it works perfectly, and we know that it's a perfect number. Okay, we checked out the logic for a perfect number, but let's understand maybe a non perfect number, right? I'll just put in 3. Now 3 is not a perfect number. Again, you can guess why, right? 3 is divisible by only 1 and 3. If you exclude 3, you only get 1. 1 is not equal to 3, hence it's not a perfect number. Again, the heart of the logic is just these lines, guys. You're using an iterator, you're trying to find it out you're trying to find out all the numbers wherein it divides it perfectly. Just add it up, compare it with respect to the input. If it's the same, it's perfect. If it's not, it is not perfect, right? We took a look at Armstrong number. We took a look at perfect number. The next thing we're going to take a look at is a strong number. Now, a strong number is similar to these other numbers that we just discussed, but here we're going to be considering factorials, the sum of factorials of every single number. If it is equal to your input, it is strong numbers, right? The sum of the factorials of individual inputs. That is what makes a strong number. Let's take an example. In fact, I have an example already on your screen here, guys. If we go on to put the input as 145, just split it into separate digits, 1, 4, and 5. Just find out 1 factorial, 4 factorial, 5 factorial. add all these up. If it is equal to 145, it's a strong number, else it's not, right? All we're trying to do is take an input, copy it to a temporary variable. We have a while loop here. In fact, we have two while loops. One is to check out the structure, break it into individual digits. The next while loop is basically the entire heart of the logic, where we're not just trying to break the number, but we are also trying to find out if the factorials add up to the sum. And once we have the sum at hand, we're trying to see if this sum is equal to the input. Look at this. If sum equal to temp. Why temp? Because we have assigned the input number to be temp, right? We're just copying it and placing it there. Now that we understood this, let me run it. Let me go on to find out 145 first to see if the logic works. It says the given number is a strong number. So let's go on to type a number which is not a strong number, maybe 12. As soon as I go on to type 12, what is 1 factorial? 1. What is 2 factorial? 2. What is 1 plus 2? Is 3. It is not 12. That's the reason why this is not a strong number. I hope this is clear with all of you all. Right, guys? Superb. I know we are discussing a lot of patterns, a lot of number printing one after the other. You have to understand, even in an interview situation, there is a very good chance you can be asked one after the other with respect to different logic. So you have to be prepared on any front to attack and solve the problem, right? So that's the reason we are trying to give you guys all these top questions wherein you can easily use this and go on to ace your interviews, right? Fantastic. Coming on to the last 5 questions. In fact, the 6th question here, it says the 25th question states, write a program to find out the second largest number in a list. Absolutely fantastic. If you have ever given an SQL interview or a database interview, there's a very good chance this will be asked. There is a very easy way to find the maximum value. Just use the aggregation function max. It's going to give you the last value. But what they want here is not the max value, but the second largest value. Not the largest, the second largest, as in one previous from that. So if I have an input, let me just go on to type this out for you guys. If I have an input 1, 2, 3. Now what is the largest number here? 2. What is the second largest number here? What is the largest number? 3. What is the second largest number? 2. In fact, let me take a different example. 4, 5, 6, 7, 1000, right? What is the largest number? 1000. But what is the number that is less than 1000 but greater than 6? It has to be 7. Right? So this is how we try to find out the second largest one. Now quickly taking a look at the logic. First of all, we have a for loop. We're trying to find the range from 1 to the digit, including the last digit as well. Here we're trying to get an input from the user. All we're trying to do is attach whatever input we got to our list and sort it out. Once you attach the number that you get in a list and start sorting it out from the last element and just print the last but one element, this again is where all your logic is happening, right? So you're inputting the element, you're attaching whatever it is that you just inputted into the list as well. And not just that, you're also basically printing it out. While printing out the logic of the list is where the magic lies. Now, as soon as I run this, it'll say, how many elements do you want? Well, I just want to input 4 elements, let's just say. So I want to input 10. I want to input 20. I want to input 4,000. I'm going to input like 6 lakhs or 60 lakhs or whatever that is, 60 lakhs, right? Now, 60 lakhs is the most maximum one. One before 60 lakhs is 4,000. So I have 4,000. Very simple logic. It's very easy to print the last one, but you're going to have to work on printing this last but one element, right, guys? It's very straightforward. At the same time, it is very vital that all of you all know about this. Right, superb. Coming on to the 26th question, it says, what is the logic to quickly swap the first and the last element in a list? Okay, wonderful. We know how to work with the list. We know how to reverse the list. We know how to find out the index of the last element, which is -1. We know the index of the first position, which is again 0. Python index is from 0. But what they are asking for is saying, find the first one, find the last one, change it out. Right? So this is where the swap logic, the heart of the swap logic is. First of all, we try to create a temporary list and just put the original list there. So it's the simple logic, guys. A equal to B, B equal to C, C equal to A. Right? You're eventually swapping the first and the last values, but the name here is just, instead of the characters that I just said, it's the list. As soon as I go on to print it, you'll see that this is our input list, our sample list, right? The input is 11, 20, 30, 40, 50, but the output is 50 and 11. You can see that these first digit and the last digit, got swapped, right? In fact, there's a meme, there's a sticker on WhatsApp with Ajay Devgan or someone doing this, right? So that's what I can think of as soon as I saw this. Okay, guys, again, all you have to do is input a sample list, write the logic to copy it. A equal to B equal to C equal to A, and you are good to go. But here what we want to find out is to find out the maximum size, and 1 minus that. Well, instead of size, why are we doing size minus 1 is the question you're supposed to be asking right now. The answer to that is Python indexes everything from 0 instead of 1. So if you have a programming language which indexes from 1 rather than 0, you'll just say temp equal to sample list of 0, 0 equal to size equal to temp. We're saying size minus 1 because we're starting from 0 with respect to the index, right? It's all simple, straightforward questions as soon as you look at the answer. But as soon as the answer is hidden and just the question is shown to you, you can stumble upon it and take some time to think as well, right? So make sure that you guys are figuring this out easily as well. Fantastic. Now that we know how to swap the first and the last element, let's take a look at the 27th program, which states write a program to count the number of vowels present in an input string. First of all, what is the input string? The input string, since we're talking about vowels and consonant, it has to be characters, right? Now, Anirudh Rao is my name. This is the input string. But to make Python understand what the vowels are, we have to specify it, right? Capital A to capital E, A, E, I, O, U should be in the lowercase, should also be in the uppercase, right? Because if you just put it in caps, Python is of course treating lower cases very much differently to upper cases because you saw the ASCII values are fundamentally different. So when I say that check for these, I am giving both the lower case and the upper case as well, right? And eventually we're just sending these both functions. In fact, this has to be input underscore string, right? We're just sending the string value, we're sending the vowel list into this to go on to compare and see if it works or not. Now, as soon as I hit enter, all the output that I should get is, first of all, it should tell me the length of number of vowels. So it's giving me the number of vowels that are present in Anirudh Rao, right? So it's A, 1, 2, 3, 4, 5. Correct? 5 different vowels. Now, what are the vowels that it caught? A from the capital I, capital A, I, U, A, O. A, O is from Rao and A, I, U is from Anirudh, right? And again, the heart of the logic is this one particular line, just to traverse with each and every single element, and you just being very careful about giving both lowercase and uppercase. It's just passing these values to a function, having it in a structured modular way to print it out, right, guys? It's fairly simple, at the same time fairly easy to get confused as well. So make sure you're paying a lot of attention there. Superb. Coming on to the 28th question. The 28th question states, how do you break a list into n chunks using Python? Now, n can be any number that I want. If I want to break this list into 10 chunks, I can do it. If I want to break it into 5 chunks, I can do it. Now, when I say chunks, let's see the output first and then work on the logic. You can see that this is the input, right? 1 to 13. Now, I want to break it into how many pieces? N is basically that. How many pieces that I want to break it into? I want to break it into 4 pieces. You can see this. 1 piece, second, third, fourth. Even though it does not have enough elements to complete the last one, it still breaks it, right? Now let's make Python a little happy. Let's just put in 13, 14, 15 and 16 as well, right? Now, if I'm breaking this into 4 lists, it's going to be equal elements in every single entity. Look at this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is 1, 13, 14, 15, 16 is 1 as well, right? Again, the logic is basically this, guys. All we're trying to do is find the input list. Now, what is this particular logic, right? We already learned this. Take a second to remember what this is. Once we create a simple nameless function for our logic, all we're trying to do is use the for loop and just traverse from 0 to the length of the input list and eventually break it down into what? Into n pieces for us, right? Pretty simple, guys. It's just a simple list operation that will tell you what is supposed to be done. What's the input? How many pieces do you want to break it? How do you break it? Print the broken output. That is it, right? 4 lines, four different things that these lines do. Fantastic, guys. Now, coming on to the 29th and the 30th question, we're going to be discussing a bit of exception handling, right? Exception handling is, again, an exceptionally important part of Python as well. There are a lot of things with respect to the keywords that you'll be using in the exception handling part. try is basically used to just put in all the code where you're trying to experiment to see if there's an exception that will occur. And except block stands for exception. If there is an exception, everything under this code segment will execute. And if your exception is not caught, as in the logic that you have put here is completely correct, this will not be executed, but else will be executed, right? Let me repeat that again. In your try block, if there is no exception, this entire block is skipped. If there is no exception, this is skipped and this is printed compulsorily. But if you do have an exception, it will come here, it will figure out there's an exception, quickly it will jump here to say that there is an exception. Let's in fact try it out. It's saying enter the first number. My first number is 10. It is saying enter the second number. Now I am a very intelligent boy. I'll put it to 0. 10 by 0 is not done. So as soon as it sees 10 by 0, it just came here, asked me for input, came here, asked me for input, figured out the logic, and it says the output is Z. But instead of it actually being able to print, there is an exception that is there inside the try block that will quickly jump to except block and print this message. You see, if except is printed, else is not printed. If else is printed, it means your logic is correct and there's no exception. Let's do it again. Enter the first number 10. I want to divide 10 by 2. Is it possible mathematically? Of course it is possible. So this entire block is not at all executed, but this is executed, right? Just take a look at this comment. This comment will basically tell you everything you need to know about what is executed, what is not executed, right? Fantastic, guys. Coming on to the last question now. The last question states, how does the finally block work in Python? Try, except, else, finally, right? We already know try. If we have to experiment something, just throw it in the try block and catch if there is an exception. We understood this. We understood the else as well. But the finally keyword, something you're really supposed to know about this is the fact that no matter what, either your exception is caught, your exception is uncaught because it's not present, no matter what, unlike the else loop, the else will only work if your exception is not, if this part of the code is not executed, else will run. If this is executed, else will not run. Finally is a good boy. Finally doesn't do all that. No matter what you try, no matter what exception you get, God bless, it will run finally, right? As soon as I go on to click this, we are basically dividing 5 by 0, floor division of 5 by 0. It says, hey, sorry, I cannot divide it. So try block got executed, except block got executed, finally block always gets executed, right? Look at the comment. It says executed regardless of exception occurrence. Either your exception is caught or uncaught, no matter what, this piece of code will always be executed, right? So I hope you guys had fun watching this particular video. I really hope that you guys took a lot of learning away from this and you're going to use this to ace your Python interviews and land your dream jobs, right? Superb. On that note, guys, my name is Anirudh Rao. Thank you so much for watching. Have a fantastic day ahead and good luck for all your interviews ahead, right? I want to welcome all of you all watching this particular video with open arms into the Python developer community, right, guys? Okay, superb. Thank you so much for watching. See you.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleague, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.